Okay, I am David, and the first thing you want to do is um, you want to create a question in a question bank. You can create it on a test document, but I think it's best if you open it on a question bank. Give it a significant name. For instance, today I'm going to do Ohm's law. So Ohm's law for a series circuit. Yeah, there you go. And what I'm going to do is I'm going to use the same name because this is what's going to show on your name. Okay, so why do you want to create it on a test bank? Because on a test bank, you always have access to it. If you put it on a test, you have to convert it back to a test bank, and it just makes no sense. And sometimes if you forget, it makes a mess. Anyway, so here's my first thing I do. I'm going to create a question, and so I'm going to create a numeric response, and I'll tell you why. If you create a numeric response question, is there is a program that will allow you, that will grade the question for you online for free, and it will send you an email of the grade. I'll show you. So let's put it on numerical. This is my favorite. You can also grade it by hand if you wish. So for instance, I'm going to say, what is the total resistance of the circuit, or of the what is the total resistance of the circuit? Okay, and so I need to create a narrative. This is the best way to create a question, because you can have the same narrative and call it as an like object-oriented programming. You can call it, and your narrative will only show once, and then you have a very lean document, if you will. And so here's the narrative. I'm going to create a narrative, and I'm going to say 3 resistor. You should have all of this prepared ahead of time, okay? So this one is going to be series. Oh, I'm going to say new. I apologize. I'm getting ahead of myself. And I'm going to name it right away so that I don't forget. I'm going to call it series 3. And I'm going to call it Ohm's law. Ohm's law. There you go. And then it will be easier. And then I will enter the narrative here. 3 resistors, are connected in series. The value of the resistors are, and then I enter R1 is equals, and I'm going to create a variable called R1. So I'm just going to put here R1. And then I'll enter the ohms right now. And then what I'm going to do is I'm going to call the editor. And so let me show you. There is a shortcut for it, Control E. I'm going to do it like this. I will enter the omega. That's the symbol for ohms. And ohms, comma, R2. I'm doing this the long way. Okay, is equals, and then I will enter a variable R2. I'm going to create that variable right now, and I can do a shortcut, Control E, and then enter the symbol for resistor, and then let me see, R3 is equals, and again I'm going to enter the variable R3. And I can also copy and paste. If you find this is easier, Control C, and then Control V, and then it will be easier. And then I'm going to say, and the electromotive force, or voltage. I'm going to put here voltage. Is V equals, and again, I will create a variable V right now, and I'm going to put volts. Yeah. There you go. or I can even put volts. I can spell the whole thing. It doesn't really matter. What I'm going to do now, I am going to insert a partition graph. And what it does, it gives my students a visual, and I want to make sure that it shows a dotted background. And then I'll leave it like that right now. Okay, and I'm going to apply it, and I'm going to say, okay. So that is my I'm going to get rid of the X and the Y axis. I like it because it gives you the coordinates, and it tells you where to put the values. So let me go click over again, and I'm going to enter a picture. I prepare a picture ahead of time, and I'm going to bring the picture. I place it on my desktop, and so I put it both as a bitmap. Notice that it's 110 kilobytes, which is not much. I also enter it as a JPEG. JPEG only uses 10 kilobytes. And so the question would be lighter. So I'll use that one. Now I use a size of 220 by 170, 220 width, 170 height, and it fits perfectly in there. So when I created it on the Paint, and so my picture is called series. So I need a name for it, and so series 3, because it's 3 resistors in series, and in this case I'm using the European symbol for the resistor. I have one for the American one, and I'm going to create both of them. And the reason why I'm teaching an IB class. Now, I want you to notice one thing. This is the width of the figure is 11. Yeah? And notice that in here, 11 divided by 2 gives you 5.5. Oh, so it centers the picture for you, the program. Now, notice one thing, that 8.55, that's the height of the program. If you divide it by 2, it gives you 4.275. Again, it centers the picture. So it makes things really nice. So if I hit on the apply button, you will see that the picture will show on the program. There it is. Yeah. And so what I'm going to do now, I am going to enter some values. So let me show you. Okay, I'll press OK. Now, what I'm going to do is if I press Control D, or if I insert variables, yeah. So I want to insert variables. I'm going to define variables. So algorithm definitions. It takes me that. Or you can do, let me see, let me show you again. Algorithm definition is Control D. So I always like to use a shortcut so that I don't get tired. So I use Control D. And it brings me to the same thing. So I'm creating a definition. If I press tab, it highlights the new button. So I'm going to enter the value of my first resistor. I'm going to say resistor 1, and then I need a range of values. You can enter a range. For instance, I prepare mine to go from 10 to 20, the first one. The reason why I do an example at school with my students where they I use a circuit where I use 20, 40, and 80 ohms. And what that does, it allows you to see the relationship between the voltage drop between each resistors. And it's really easy for my students to see a numeric. Anyway, so I'm going to leave it like that, 10, 20, 30. What it's going to do, the program is going to create a resistor 1 is going to go, is going to range from value 10 to 20. So I'm only going to have 2 choices. I can go 10 to 20 in ones, and then it will create me 10 different values for it. So I'm going to create a new one, and R2, I'm going to go from 20, I plan on using it from 20 to 40. So 20 to 40, and I'm going to set some 10. And I'm going to say, okay. So I will now create my third resistor. So resistor 3, and I need a range. And my resistor 3 goes from 40 to 80, and then from 40 to 80, it says sub 10. So now I will create my, my voltage. Yeah. And so my voltage, and that's going to, or electromotive force, the range is going to go from 110, and now we're going to make it all the way to 150. And we're going to go steps of 10. So I put a comma, and then I go by 10. So again, this will take the values of 110, 120, 130, 140, and 150. Now, in this question, I want to ask the students for the total resistance. And so, and I'm going to call this the resistance in series. Yeah, RS. And I'm going to say the resistance series, it will be defined as R1 plus R2 plus R3. And that's it. Now, some of the students will not tell the difference. So to do that, I am also going to enter the formula for the parallel resistance in case they enter the parallel resistance. So I'm going to get the resistance in parallel, yeah? And that will be parenthesis R1 times. To put times, you put the asterisk right above the 8, multiplied by R2, multiplied by R3. Yeah? And then I divide by, and then I use parentheses. Yeah? And the formula is R2 times R3, R2 times R3, and then plus R1 times R3, R1 times R3, and then plus R1 times R2. So R1 times R2. Let me see. I'm missing R1, I'm missing R2, I'm missing R3. So my formula is correct. And I'm going to leave it as a general number. You'll see why that is important, and then we'll adjust the numbers. Yeah. And this is in case somebody doesn't know the difference between a series and a parallel, they can enter that as a value. I'm also gonna ask for the current. Yeah. So I'm gonna ask for the current in the series. Yeah. So I can also write comments on it. I'll show you how to write comments on it so that you don't forget what it was. So the current in series for this, let me see, is voltage. It'll be voltage, yeah, divided by, I can enter RS, or I can enter R1 plus R2 plus R3. Now, for me, it's better, I think it's better to enter the whole thing, because if I round RS, then it will affect the value of IS. So I can enter a comment also. I like to enter comments every now and then, whenever there could be a confusion or I could forget what it is. You put the hash sign or the number sign, and you said, this expression calculates the current for a series circuit. That's if you want to. So anything after the hashtag sign or the number sign, it will not be evaluated. The program will ignore it, so it will take it as a comment. So I got my current. I can also enter the current in, for something else. I want to, in this question, I want to ask for the voltage drop. So I'm going to say voltage 1, and the formula for voltage 1 is actually parenthesis voltage, see, resistor 1 times voltage divided by let me see, R1 plus R2 plus R3. So R1 plus R2 plus R3. Now, sometimes you want to be economical when it comes to, or you want to save time. So what you can do is this. I know I'm going to use the exact same formula for the next expression. So I'm just going to press OK. I'm going to say new, and I need voltage 2. So the voltage drop across resistor 2, I just enter because it's the same formula, and I make sure that I put resistor 2 there. There you go. I also need voltage 3, and notice how it saves me time. There are other ways to save time. I can also use the current as resistor 3, but again, if I have a value there, or if I round one of them, then it carries that rounding and it makes it difficult. Okay, so what about power? Okay, power in this circuit is equals to current times voltage. So let me see. So that will be the current in the series circuit, yeah, multiplied by the voltage, total voltage. And then do, and then I want, I can also ask for power 1. And so the power resistor 1, power and resistor 1, it will be current in series times current 0 multiplied by resistor 1. So the current in series multiplied by the current in series multiplied by the resistor 1. And so I'm going to use the same one. And so Control C. And it saves me time because power 2, it will be the same thing except that it will be resistor 2. And then power 3, and it will be the same thing, but it will be resistor 3. And that saves me, again, a lot of time. Let me see, am I missing anything? And then that's it, yeah. So now look at this. So that is I created the variables. And so I need to enter these values in here. This is my variable, R1. So I press insert a variable and automatically jumps in there, yeah. Because it knows that R2 is a variable. So I say insert a variable and it puts the value of R2. And then I'm going to do the same thing for R3. Insert a variable. You can also do this. You can go insert and then variable, and then you choose the variable. So the variable I'm looking for is V, and it will do that. Now look at what happens. If I press this calculate, I made a mistake. Control D. What happened? Did my, it's probably my comment. Okay, I'm going to erase it right now. Let's see, R1 plus R2 plus R3, everything. Oh, I didn't put the division. Okay. It's voltage divided by total resistance. Okay, it's very easy. You make one little mistake in programming, and it gives you an error. Now look at this. This is the beauty of programming. I got resistor 1 is 10, resistor 2 is 20, resistor 3 is 40, and voltage 150. If I click on this that says calculate values, notice one thing, it gives me 10, 30, 80, and 120 volts. If I do it again, it would change the values over and over. And that is the power of programming. Now, I want to help my students so they can see what's going on, so they can get a visual, because most learners are visual, according to educators. So what I'm going to do is I'm going to enter those values in here, the variables. And the way you enter into the diagram, you double click on it. And I said, you can enter a box, you can enter a point. I think the box is the fastest way to enter the values. The point is annoying, but I'm going to show you both of them. So I'm going to enter a box for R1. So it says enter an R box. Well, I got the value of resistor 1 in there. Now here's the beauty. You can change the font. I'm going to change the font. I'm going to put a boldface, and I'm going to put a 14. If I need to change it, I can change it. You can change the color of the font. I'll go there and I apply it. Now notice one thing. It places it at the center, at the origin, at 0, 0. Well, I need it a little bit higher. So I need this at about 2.5 and at about 0.5. So I said, oh, so I need this at 0.5 and I need this at about 2.5. And then you can adjust it as you go along and check it out. When I say apply, notice it went a little higher. So maybe the Y is too high. So I'll go 2.4. And now that seems perfect. Now, if you think the font is too small, you can go back and change it, So it might look kind of small to your eyes. So I'll put it at 16 and I'm gonna apply it. And then there you are, And so now I say, okay. You can also, well, let me enter another box for this. So, and then I'll show you how to enter it as a point. But I prefer the method of the box. So R2, I noticed that the font 16 and boldface work best for the size of the letters, the characters. So if I apply it, it's going to go to 0, 0. Well, I need the center at around 4 and 0. So I need the X to be at 4, sorry. I need it at 2. So right here, it will be the center of the value. So I put 2 and I apply it. Now notice how it looks there. I think it looks reasonable, so I'll leave it there. So I press OK. Now let me show you how to enter it as a point. I do not like it as a point, but one advantage of the box is you can tilt it, yeah? So let me just show you. When you have a ramp, you can put here 45 degrees, and look at this. It will look at 45 degrees. Isn't that nice? So that's another advantage of the box. That's why I like the box. There is more you can apply, you can do with it. Now I can enter also as a point. So I'm gonna put point. And so I wanna enter it at right here. So I'm gonna leave it at this at 0, 0. Well, let me put a coordinate. I'm gonna enter at 1, negative 2.2. So 1, negative 2.2. And the reason why I want it there, because here is the coordinate 1. Here is a coordinate about negative 2.2. And then it will place it there. I might move this to 0.5 because it's putting it on the X direction, okay? I don't want a point. And I'll show you what it does with the point right now. And I want this to be R3. So this is, again, another way to label the resistor or the diagram. I want to stay consistent with the font. So I'm going to use boldface, and I will use 16. And I'm going to say yes. I apply it. Now notice one thing, because it is selected right here where it says label position. If I use this, it will make it gives it about half a point there. So and one way you can control this, you can put it right here as 0 and then or 0.5. You know, let's see what happens. Put it as 0. That seems to work perfect. So now notice what happens if I use a point on it. So if I put a point on it, it places a point at the coordinate 0, -2.2, and it places the number on the right-hand side of that center. Yeah. So this is the way you can look at it. Well, so I don't want the point on my diagram. So I'm going to erase it, and I'm going to apply, and there it is. Now I just need one more, and I'm going to use the point once more so you can see it. I don't need a tilde, but I want you to see that it seems easier to use the box. There are lots of ways to do this. So I'm going to place new. I'm going to say I want this at -4.5, -4.5, and I want it at 0 also. Let's see what happens. It seems that 0 works good because the point will be placed here. I'll leave the point there so you can see it. And I want it to be voltage. So here's my voltage. I take a font, I use boldface, and I use 16. That's okay. And then I will apply it and look at what happens. It's a little bit too close to the equal sign, so I can go back and I say, well, you know what? I needed a 4.3, -4.3. So I apply it. That seems more perfect. So I say, I remove the point because I don't want that point. The point tells you, it puts it at this coordinate. So I apply it, press OK, and I press OK. And now look at what happens. I have my diagram. Now I don't want the X and the Y axis. So let me go back. The way you remove it, you just says, I don't want to label the X. I don't want to label the Y. I don't want to show the tick marks, the label tick marks, none of that stuff. And I do not want the axis itself. I do not want the axis. I don't want the X or the Y axis. So if I click on apply, look at this. Magically, everything is gone, but it allows you to manipulate this. Here's another advantage of this. If you use a 2-column test, oh, this will give you a 2-column test. So I'm going to go this way. I'm going to go this way a little bit more. So it occupies less room. And here is a question in the IB format. So I am done with this. And it says, what is the total resistance? I misspelled resistance. Oh, good, good. So let me fix it. I'm glad I cut it. Of the circuit. So all I do is I insert the variable and I put resistance in series. And I insert it and I put ohms. So I can enter the letter. Remember, Control E takes you to the equation. And I put the omega and I say record and it gives me the ohms. Now look at this. When I press this, my total resistance is 110. Let's take a look at it and see what it looks like. Again, 20 plus 40 is 60, 60 plus 50 is 110. And again, the beauty of this is this. I can click on this and I can change values and it will change my values here. That is the advantage. Again, if you want to create 3 versions of the test or 20 versions of the test, you can literally produce 1,000 different tests if you go by files or if you'll see once we get all the combinations. Okay. So I wanted the total resistance. Well, you know what? I also said that I was going to ask for the current flowing through the circuit. So I'm going to create one, and it says, what is the total? Well, Now I want to say, what is the current flowing through the circuit? So, or I can change format and say, well, how much current flows through the circuit? And I know the answer for this, it will be, I got my variable. So I go to the variable and I know it's current, current through the series circuit. I press enter and it is, the units is ampere. Okay, the unit is ampere. So there it is. And let's take a look at it. And there it is. I get 1.09. We'll fix that right now. I just want you to see what you get. Now here, it allows me to enter a decimal grade. Now, why is this important again? Your computer, you can deliver this, send an email to the students or put a link on Dropbox. The student opens it on a Chromebook and they answer the questions and they enter the values there. They can enter the values there and the machine will grade it for you. So you will get an email with the grade of the student. If you have 20 students, it will clump all of the scores into one single email and you just download them, not download them, just copy the scores and enter it into the grade book. That is excellent. Now, because it is in series, every resistor has the same current. So I just say, I'm gonna ask 3 questions. So how much current flows through resistor 1? Well, it is the same current because in series through resistor 1. And it's the same answer. And so how much current goes through resistor 2? I can just answer, but this one already has the wording. So I'm just gonna duplicate. I say Control D and it duplicates it. And so I'm gonna say now to resistor 2, and they all have the same current, yeah. And then what about through resistor 3? And again, I go to edit and then I say, copy the question. What is duplicate? Let me see, question. I want to duplicate the question. So I duplicate the question or I press Control D. And now I ask how much current flows through resistor 3. And you know what? I want to be a little bit more formal. I'm going to put capital S. And again, they all have the same current. Yeah. So but this is not a lesson on resistors, it's on programming. So let me okay. So let me instead of running the current running through the circuit, I plan to ask what is the voltage drop across resistor 1? Oh, so instead of this, I'm going to change that question. So, or I can go over here and I can say create new, and I'm going to get a numeric response. And I said determine the voltage drop across resistor resistor 1. Now, notice one thing it says here, narrative. It says none. If I try to enter an answer right now, if I try to insert a variable and I say insert a variable, there is nothing because I don't have this associated to the narrative. And so that's like I created an object. And so I need to go back to that object. And then when I click on it, now it is associated. So if I enter an answer and I say, oh, insert variable, and I call this voltage 1, V1. And so, and this is volts. And so if I look at the values, take a look at that, 10.999. And I need to have 2 decimals. So decimal grid. I can also put 1 decimal if I want to. Yeah. I'll leave it as it doesn't really matter. Okay, no, it does matter. I'll show you. I'll show you. And so now, let me see. So I can take this. I can take this question. Yeah, and let me erase this one. So delete. Yes, delete. Now I want to determine the voltage drop across resistor 2. So again, I can go to question duplicate, yeah? Or I can write Control D, and that gives me the same question, and I can edit it. The bad thing is, if I made a mistake on the first one, it will inherit that mistake. But the narrative is correct. So instead of voltage 1, I would like to insert a variable called voltage 2. That is voltage 2, press enter. And now it is the voltage. And then, I didn't put a point there, a period. And so I can change this. And now I want to find the voltage drop across resistor 3 and insert variable, and I can go to all the way to voltage 3, and there it is. And now I can look at the values. So I have now, here's the beauty of, again, the beauty of programming, the beauty of object-oriented programming. I created an object or a narrative, they call it. I can call that object or that function or that algorithm, and I can create a lot of questions here. Yeah, that is, and it does it for me. So if I'm teaching a lesson on current, on resistance, I can use it. If I'm teaching a lesson on resistance, I can use it, on current, sorry, and I can even use a correct language, voltage drop. Okay. So let me create one more. I noticed that I calculated the power. So I can go to power. So I can say, I'm gonna copy this one. This one is said, I want to find the power dissipated by resistor 1. So I can say compute or calculate, doesn't matter, calculate the power dissipated by resistor 1. And power is given in watts, so I need to change the units to W, or I can put watts, it doesn't matter. And I need to enter a new variable. So insert variable P1, because that's power 1. And when I look at it, it gave me a decimal, so I'm gonna go decimal grid. Oh, it already had it, okay. So I can do the same thing now. Oops, I pushed the wrong button. I can calculate the power dissipated by resistor 2. And then I make sure that I enter the insert variable P2. And I'm gonna check the value, there it is. Now, let me show you, remember I show you, you can also create new, and I can say numeric, I can say calculate the power dissipated by resistor 3. Now notice that it takes me longer because I already have that format. So I just want to show you that it takes longer. So I go decimal grid, and then I press insert variable, and I'm not associated here, you see? So I got to associate it. I got to click on this. So it's much easier when you just duplicate the previous question. So I want to insert variable and I want to insert power 3 equal. And power is given in watts. And so I want to see the value, and that is the power dissipated by resistor 3. Now, how do I fix this? Yeah. Notice that I'm getting a lot of decimals, so I can go back to my program. I can open the narrative, click on the narrative. I put Control D or edit, whatever is easier. Yeah. Edit the algorithm definition. And then now notice that let me see, the series current, the series gave me a large decimal, give me lots of numbers. So what I'm going to do is this, I'm going to say, look, I want to go to 2 decimals. So I want to round to 2 decimals. So I can round it to 1 decimal. Let's put it 1 decimal. 1 decimal. I'll change everything to 1 decimal. There you go. And I can change this to 1 decimal. So I go general, number, and make sure you click on fixed, because if your number is 0.01, it will not show the 0.0. So you put fixed, it will show the 0. And there's another way to do it, but I think this is quicker, especially when you are defining your variables. I just wanted you to see the advantage of doing this. And so again, I go to number and I go to 1 and power. I also wanted 1 decimal. And so notice I got to do this on all of them. And there is one more thing I want to tell you on this. And again, I'm thinking about my students, and I'm thinking as an educator. On the IB exam, you got to use the same number of digits. So what I need to do, the same number of decimals for the most part. So I need to put this with 1 decimal. Now notice one thing, at the beginning, it was giving me 10 ohms. Well, now it's going to give me 10.0 ohms. And this one, if it was 30, it will give me 30. Now it's going to give me 30.0. And that way we can use the rules of significant digits. And so this one, I'm going to put it right here, and I'm going to put 1 decimal and fix and okay. And I am also going to put it here. Yeah. And that way we can apply that rule. Now, notice what happens now. I'm going to close this and I'm going to record it. Now, instead of 10 like this, it gives me 10.0, 20.0, 70.0, and 140.0. Now, look at this. If I look at my answer key now, instead of giving me 1.439, blah, blah, it gives me just 1 decimal. And so, and I'll need to go back and change the boxes. Notice one thing right here. So I have 2 decimals. I gotta go and change this to 1 decimal. So I'll change it right now off the screen. Well, what if you want to, this is gonna be a long video. What if you wanna create multiple choice? Oh, so I'm going to create a new video for this. So I'm going to stop there. So